So good afternoon, everybody. My name's Andy Gill from Rittal. First of all, pleased to be back at the 2024 Global OCP Summit. So what we'll be talking about it for the next 15 or so minutes is based around a modular cooling solution that we've developed in response to some of the questions you see at the moment. So, predicting the future. When will liquid cooling data centers go live? Some of the questions we're hearing constantly. How do the architects out there develop new data center solutions with the ever-changing needs of what it was and what it's accelerating to at the moment even? What are the possible stepping stones to liquid cooling? What cooling capacity is needed and when? Do we need 100 kilowatts per rack now? Do we need it in 8 months' time, in 2 years' time? All these questions are outstanding. And last of all, how do we ensure the capacity that we're deploying is number one, fit for purpose, and also protects our long-term sustainability targets? There's no point buying and deploying products up front and sitting there. So in response to all of that, Rittal have developed a platform portfolio of direct liquid cooling, and it's really based on a platform strategy. Number one, it's modular, making it highly flexible. We can start anything from 30 kilowatts, and I'll go into a bit more detail in a minute, all the way through to 100, 150 kilowatts, and then as we got into a single rack solution, 1 megawatt and beyond. In other words, you can pay as you grow. You might decide to deploy 50, 100 kilowatts today. In 6 months' time, ramp it up to 150, 200, 500 kilowatts, using the same equipment, just being scalable. Everything in there you see is pretty much hot swappable. So it allows the workloads, and particularly the AI workloads, to continue to operate. So all of the pumping units, the heat exchangers, the battery backups, everything hot swappable and very easily. And of course, high levels of redundancy, meaning high availability. So, and I'll go through some of that detail. So we're looking at it from a complete solution point of view. The rack, 19-inch, or of course, that with the OCP show, the 21-inch ORV3 product. Cooling with CDU, CCUs, manifolds, rear door hexes, and sidecar type units. Monitoring through a control modules, and last but not least, of course, the power, whether it's battery backup or it's PSUs and buzz bars rating from 20 kilowatts all the way to multiple hundreds of kilowatts as we're going into next year, I guess. And the portfolio, the main portfolio that we in Rittal have developed and to support this is based around liquid to air and of course a liquid to liquid to allow that step change from air and into liquid into the future. Rear door heat exchangers, liquid to air, around 35 kilowatts for the OCP 21-inch product. Side cooling, 55 kilowatts for 21 and 19-inch type products. And then going into the liquid to liquid, we have CDU in-rack and CDU in-row. And the in-rack is available in both form factors, 21-inch and 19-inch. And within that very small 4 OU footprint, 150 kilowatts of cooling capacity. And as I've said before, it can be scaled. Right the way across to the Inrow Solution, as you can see on the bottom right, which is 1 megawatt within an ORV3 rack. And of course, all the manifolds and accessories that go with it. So our approach generally is to take our main platform as a portfolio and offer a complete solution, a DLC-ready ORV3 product. And allowing us to do that in a platform approach, it allows the user, the data center, to plug and play, basically. They can wheel in a 30 kilowatt unit or a 60 or 100 kilowatt, and it's basically sized right at that point in time. So an end user doesn't need to call a power shelf supplier, a buzz bar supplier, a CDU, and figure out what power they need, what cooling capacities they need. It's all done here as a complete solution. So we can offer a 60 kilowatt solution with an in-rack CDU, the right size power shelf, the right size buzz bar, all enveloped within the ORV3 rack. And we've been able to do that because of our approach on a platform-based architecture. So most of the components with it are highly standardized across our whole range. So everything from the control module to the pumping modules to power and all the sensors within it. So for example, on the pumping modules, we have the same form factor for what we have on the Inra CDUs, which is up to 150 kilowatt with heat exchanger all built in, up to the 1 megawatt unit, which is a pumping unit that's on its own with a capacity of up to 250 kilowatts of actual pumping capacity. So much of the components inside it are standard, they're all interchangeable, and of course there are some small changes. But having this platform allows us to build a complete system very easily. And in the future for end users, if you want to scale up, you can pretty well add components to it. So a little bit of deep dive on some of the components. And we have some of these components on show at our booth, both here and on the outside on the entrance. But this is an Inra CDU, just some facts and figures around it. All within a 4OU footprint, we can develop something like 150 kilowatts at an 8 Kelvin approach temperature. All N+1, so within that single unit there, the Inrow Solution, we have 3 pumps. One is typically idling, whilst 2 are running. So 150 kilowatts, N+1 redundancy. As you'd expect, PG25 as a liquid interface, and all the required approvals that we need, CE, UL compliant across the world, UL listed, etc., etc. And then going from that extreme to the other, which is our full Inrow solution. This is a 1 megawatt solution. It's highly modular, highly flexible. So at the base of it, you can see it's a disaggregated CDU. It is a very large heat exchanger at the base and 5 pumping units. And those 5 pumping units have got the capability of pumping around 250 kilowatts of cooling capacity each. And as you can see, 4 times 250 is a megawatt, leaving one as a redundant unit. And of course, that can also be scaled. It's also within the form of an ORV3 rack. Incredibly compact and incredibly modular. Some facts and figures around it. I've already said 1 megawatt at a 4K approach temperature delta. N+1, built on ORV3. Everything within it is powered off the 48 volt backplane at the back. So whether it's, of course, the standard OCP components, the power shelves, the BBUs, all come off the bus bars, but so do all of our CCUs and our CDUs. And they all slide in and are powered off that 48 volt nominally bus bar. So how do we know it's 1 megawatt? I mean, we could claim it easily and have no evidence of it. We set it up and we test it, of course. So within our facilities, or outside our facilities in this case, we basically pulled in a 2 megawatt heater unit, fuel on the secondary circuit, hooked it up to the primary circuit, and we tested it. And we ramped it up to full power, just over 1 megawatt. We watched it stabilize, and we nominalized, and we recorded all of the output from it. And some of the cooling curves we got from it, it did exactly as we predicted. So we're confident, or more than confident, we've proven it's 1 megawatt with a 4K approach temperature delta. So some of the applications around it, and give some examples of this modularity. This is a very typical example, 10 IT racks operating at 100 kilowatts each, possibly. And on the end, as the name suggests, an Inrow product sitting right at the end, 100 kilowatts each. I mean, if those racks, as an example, were operating at 50 kilowatts each, half a megawatt in there, you could scale this one down a little bit and scale it up at a later date, in a few months from now. Another example, maybe you want to save your white space a little bit more. So you're running precious space within your white space if you're running any of the high power products. So you want to put it out into the gray space somewhere outside the fan walls maybe. This is an example of scaling it from 1 megawatt to 2 megawatts. So outside of that space right now, there are 2 of those 1 megawatt units operated, plumbed into the white space, operating some very high power products if it's needed to go to that level of scalability. And beyond that, a fully skidded unit. Again, scale up again, going from 1 to 2 to 3 megawatt of cooling capacity. All ready to go, plug and play, can be lifted into the white space or gray space, wherever you want to put it, and plumb it in, and we've got 3 megawatts of power running. So all of that really shows a lot of the modularity. All of this, in summary, was gained on an approach that we had in the architecture. We firmly believed that we needed to have a platform and an architecture that allowed us to be modular, to be incredibly flexible, because there's so many unknowns around at the moment. Of course, we're accelerating from 100 kilowatts very quickly to 200 kilowatts per rack, and even beyond that much quicker. So it was very, very critical to us when we developed this platform to have it modular and scalable. So for those who haven't seen it, please come over to our booth. We're over at booth A24. We have the actual 1 megawatt unit there that's been through all the testing, as well as some of our other products, the 150 kilowatt CDU, and outside in the entrance hall, we also have the 1 megawatt standalone unit over there. And whilst you're over our booth, you can register and take a look. We're looking at some Quest glasses as a giveaway. Come over and have a look at them as well. They're running a data center virtual reality display inside it. You can virtually play with this 1 megawatt unit using the Quest VR glasses. So it's pretty cool. Come and have a look, register, and maybe win one. So with that, thanks very much.